We have just introduced the Spark code and Spark Circle. Then let's focus on Spark structure streaming. As we mentioned before, structure streaming is new to Spark version 2.0 and later. Actually, it's an engine built on Spark Circle to process streaming data. It's programmed by Scala and it has a good fault tolerance capability. The structure streaming uses a concept called unbounded table for processing the streaming data. So, what is unbounded table? Here, this is just a demonstration of an unbounded table. So, an unbounded table means that it has no lower limitation, and we can always add new rows below the latest one. Therefore, we can always map the data stream into this unbounded table. Consider the data input stream as input table. Every data item arriving on the stream is like a new row appended to the input. And then, since we have a table now, Spark could just use standard circle statement for query to obtain data from unbounded table. In each trigger interval, updated data will be synchronized to unbounded table, and each query operation will generate a result table. Whenever the result table is updated, the updated result will be written into an external storage system, usually HDFS. So the results of the Spark tasks are stored in HDFS in most cases. To illustrate the usage of this model, let's have a look at a typical example, the word count example. The first line is the input. On the first time point, we get our data, cat, dog, 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 like this. Then, Spark adds them into the table. And the query action generates the result table like this. The result table would be stored into HDFS eventually. Then, on the second time point, we get a new record, which is all cat. So the new record is added to the tables as new row. And on the third time point, things are exactly the same. And for complete mode, since it might generate some unnecessary result, if we have less demanding on the completeness of our result, we do not need complete mode either. The last part is about Spark streaming. Spark streaming is a real-time computing framework built on Spark to expand the capability of processing massive streaming data. As we have mentioned, it involves a new idea called micro-batch processing. The basic principle of Spark streaming is to segment the input data by second or millisecond, and periodically submit the data after segmentation, which decomposes streaming programming into a series of short batch jobs. Well, simply speaking, it works as flow. Spark streaming receives live input data streams and divides the data into batches. And then the mini batches are processed by the Spark engine to generate the final stream of results in batches as well. One more thing to notice is that Spark streaming provides a high level of abstraction called discretized stream or D-stream, which represents a continuous stream of data. These streams can be created either from input data streams sources such as Kafka, Flume, or by applying high-level operation on other D-streams. Internally, a D-stream is represented as a sequence of RDDs. This plot illustrates the mechanism of D-stream. The window slides on the D-stream and the RDDs within the window are merged and operated to generate a window-based RDDs. We can find there are always some overlapped parts, and the window can also be determined by two parameters, window length and the sliding window interval. In fact, Spark streaming and Storm are both excellent in the real-time computing field, but different in specific scenarios. Spark streaming is only superior in throughput to Storm. Storm is recommended in scenarios where even 1 second delay is unacceptable. For example, a financial system requires real-time financial transaction and analysis. If a reliable transaction mechanism and reliability mechanisms are required for real-time computing, that is, the processing of data must be accurate, Storm can be taken into account. On the contrary, located in the Spark ecological technology stack. Spark Streaming can seamlessly integrate with Spark Poll and Spark Circle. That is, delayed batch processing, interactive query, and other operations can be performed intermediately and seamlessly on immediate data that is processed in real time. This feature greatly enhances the advantages and the functions of Spark Streaming. Well, there are all the contents of Spark, which is a kind of memory-based computing engine. We have learned the structure and some key principles of it. I will appreciate it if you can review them after this lecture. Next time, we will learn another component, which is Flink. See you next time.